Hello, students. We are on week 7, Algebra lesson 5.1, Understanding Linear Functions. Now, for this week, the vocabulary is in front of you. You need to know what a linear function is. We've gone over this a little bit before. It's just a graph that is a non-vertical or straight line. So it's just a regular graph. Constant change, right, is the difference between the y values is the same between each other. That means that, for example, the difference between each one is a constant change. That means that if we have our x and y values like this, right, and then the y value, they start jumping. Like, for example, if this is 1, 2, and 3 here, after you put these x values into your equation, your y values are going to come out um, to the same distance from each other. So let's say this is like 5, this is 10, and this is 15. There is a difference of 5 in between each of the previous numbers. That's what it means to have a constant change. That means that when you increase the x by the next number, the y increases by the same amount or by a similar amount. Um, Anyways, the key that we're going to focus on for this lesson is standard linear form that was introduced a couple of weeks ago. However, we're going to look at it more closely this time, and this is all about just learning what to do with standard linear form, right? So standard linear form is ax plus by is equal to c, where a and b are real numbers, and a and b are not 0. Notice that a and b cannot be 0 because a is attached to the x and b is attached to the y. If a and b are 0, then those things cancel out and we don't have a linear form. We don't have a full equation anymore. That's why they cannot be 0. They can be 1, they can be 2, they can be any other number, including negatives, right? They could be -1, -2. It doesn't matter as long as it's not 0, right? And if you notice C, it doesn't say anything about C. It just says that it has to be a real number, which means it technically C can be 0, right? That won't actually affect it. If you don't have a C value, it doesn't affect your equation as much because its C value is just 0. It's still you're still able to graph it. Okay, and that'll make much more sense later on. Okay, so let me go ahead and move this. In order Any ordered pair or coordinate point that makes a linear equation true is a solution of the linear equation in two variables. The graph of the solution represents all solutions to the equation. This is the principle that we're going to be working on this week, right? Um, so what does this mean? Well, a couple things. For starters, you're going to see problems like um, the problem is going to tell you like this, or example problem, determine whether the equation is linear. If so, graph the equation. Well, what this is saying is uh, it's kind of making reference to this right here. Any ordered pair, right? That means that any x and y that we put into an equation, right, is supposed to solve that equation. And if it successfully solves that linear equation, we can graph the results on a graph, which is exactly what you're going to do, right? So we start off, right, with this. We're here now. The equation is 5x plus y is equal to 10. The problem is asking you, hey, determine if this equation is linear. If it is linear, then graph the function, okay? So how do we do this? There's a couple different ways we can determine if something is linear. The easiest way is through the power system, right? However, before I go into that, let me explain to you how they want me to explain it, right? The way that you can use it is to compare it to the linear form, right? So here we have step one. To determine if an equation is linear, compare that equation to linear form. Notice how I have the original equation written there, 5x plus y is equal to 10. And right underneath it, I wrote the linear form, ax plus by is equal to c, where c is a constant. Remember, a constant just means that it doesn't change. That means it's just a regular number. So is my original, I need to ask myself, is my original equation 5x plus y is equal to 10 in linear form? Ax plus by is equal to c. So if you see, we're going to compare those two, right? We have 5x plus y is equal to 10. We have ax plus by is equal to c. Well, c is a constant and 10 is a constant, so far so good. The 5x, the x is fine, and a is equal to 5 in this case. This is going to be useful later. But yes, that matches. There is a number. A just represents a single number attached to the x. In our original equation, the 5 is attached to the x. So yes, that checks out. That's a linear form. As far as b is concerned, right, there's nothing here. But in reality, when there isn't anything there, there's a hidden 1 in front of that y, which means that b is actually 1 in this case. And yes, we checked them off. This equation is officially in linear form. We have just proven that it's in linear form. The first step is complete. Since the directions say determine if it's linear, yes, it's linear. Now I need to move on to the next steps, right? Another way you could have determined this is if you locate the highest power onto the on the equation, right? So if you see something like this, right? If you saw something like this is the power of 2. And there, every variable has, if it doesn't say anything, it has the power of 1. The power of 1 is referring to the linear form, right? So if all of them are just regular variables, where there's nothing on top of the x, there's nothing on top of the y, there's no little numbers on top of them, they are hinting that that is in linear form, right? Um, it's possible that it cannot be in linear form for other reasons, but if you see a square in there, it's automatically not linear. I'm talking about this one here because of this. If there was a 3 instead of a 2, it would be not linear. If it was a 4, 5, a 6, a 7, it doesn't matter. If it's anything other than a 1 or there's just nothing there, right? And in any part of that equation, then it's not linear. And that's a shortcut. You're going to be able to see that on one of the problems, right? There's going to be a really complicated problem. It's going to have a bunch of exponents on there, right? But if you remember this part where you're just like, oh, if it has an exponent higher than 1, it's not linear. I don't have to do this. All you have to put for your answer is not linear, and then just move on. But if it is linear, like this one is, we got to move on to the next step. Okay, since the original equation matches the linear form, we move on to step 2. Step 2 says, check if the value of a and b in the original equation is not 0. Now, this is where, remember I said that we were going to use this later? Well, we're going to use this in step 2. We just need to double check that in the original equation, there's no 0 in front of the x. And you're almost never going to see that, but you should still check, right? So in this case, a real quick check, we need to recognize that a is the number in front of the x. In this case, it's 5, right? So since x is 5, x is not 0, which is good. That checks it off. Y happens to be 1, which means that y is not 0. That checks off. All right, so we've established that that follows the next rule, right? Therefore, the second condition is met. If the second condition is met, we can move on to the next thing. All right, so step 3, what are we going to do now? Now that we've proven that it is linear and that it follows the conditions being linear, right? It's in linear form. A and B are not 0. What are we going to do now? Well, we solve the equation by isolating the value to the left side of the equation. What that means is we need to convert this from linear form, right? The original equation right here. This is in linear form. This is in, once again, AX plus by is equal to c, and we need to convert it into y is equal to mx plus b form, right? This should look familiar because this is what we use to graph. And since our goal is to graph this at the end, we need to change this, right? So what are we going to do? Well, if you notice here, y is by itself and it's on the left side of the equation, which means that for us, in order to convert the linear to y equals mx plus b form, we need to do something called isolating the y. We need to make sure y is by itself. How do we make sure y is by itself? We subtract that. We get rid of that 5x. We need to move that 5x from the left side of the equation to the right side of the equation. So if this is a positive 5x, I do the opposite of that. I'm going to subtract 5x from both sides. That's what I have here. This cancels out, and I'm just left with y. This y just came right down, right? Is equal to, and since I have an x and the 10 is a regular number, I can actually subtract them. The 10 kind of moves over to the right. We have negative 5x plus 10. This is the equation in its slope-intercept form. Okay, good. This is the end of step 3. We have our equation. All right. So now that we have our equation, it's in the form that we can graph. We're going to get started on the next step, step 4, which is we're going to make a table of values for our new equation, right? When we're making a table of values, I think last week or 2 weeks ago, if I had you plug in domain values in here, this time what you're going to do for all the problems is your x values, unless you're told otherwise, unless the problem says I specifically want you to put these numbers for x, you are going to use the easiest numbers we can use to graph these. You're going to plug in -1, 0, 1, 2, and 3 for all the problems that you have in their homework and practice. As far as the graphing linear equations problems go, you have about 6 of them, so they're not that many, and just use these for those that you end up having to do this to. Remember, for all those 6 problems, you're not going to have to graph all 6 of those because some of them are not linear, and you're not required to do that. You're only required to graph the linear ones, okay? So when we make our table, if you notice here, this is my original equation right here, okay? So now what do? If you're asking, again, if you're wondering where I got the -1, 0, 1, 2, and 3 from, I just made them up. I'm plugging in the easiest numbers for x. The easiest are the ones that are closer to 0, so that I can get a y and I can start graphing my x and my y. The results are my coordinate points, right? So you always want to pick easy numbers like -1, 0, and 1. The 2 and 3 are just there for added effect, but really the core is -1, 0, and 1. You need to use those for every single problem. So if I plug in -1, right, my original equation is down here, -5 times -1, because I'm going to plug in this one right here, right? So I plugged in -5 times -1. Negative times a negative is going to give me a positive, right? Which means that it's +5 plus 10, right? But the 10 is just kind of there because that was my C, and it's a regular number. 5 plus 10 is 15. My y is 15. That's how I got this. And that's my first coordinate point, -1, 15. And that's what I'm going to graph in the next step. But I'm going to fill out my chart, right? Right here, I started off with the equation again. I plugged in 0 this time. -5 times 0, anything times 0 is just 0, which is why I have 0 right here in the next one. 0 plus 10 is just 10. That's why 10. That's where 10 came from. So that's 0 and 10, 1 and 5, 2 and 0, 3 and -5. I did the math off screen for those. I don't want this to take too long, so I'm going to just leave it at that. But you can feel free to double check on your notes if you want to plug them in and see if you can get the hang of it. See if you plug in 1 instead of x, and see if you end up getting 5 at the end, right? If you didn't, go ahead and make sure to write those down in your notes. And when you upload them, just kind of circle it and be like, I don't know what I did wrong here. And then I'll help you guys out, okay? So the last step here is to graph the coordinate points. I put the coordinate points on the side here, and I'm going to graph them. And I'm going to really confirm if this is a linear function. Even though mathematically, because we've gone through all the other steps, I know for a fact that this is a linear function. The directions specifically said I need to graph them. So I'm going to graph them. -1 here. I'm going to start, since this is my x and this is my y. X, if you don't remember, is from left to right, and y values determine up and down. So -1, right, would be over here, right? -1 down here. Then I go up to 15. Yes, that is a 15 right there. And 0, 10. 0, 10. Now I did these in variables of 3, so I'm kind of just gonna eyeball it there, right? 1 and 5. So 1 and 5. 5 should be right below the 6. So somewhere right there. And then 2 and 0. 2 and 0 should be right there. Okay, so now that I have all my points on here, I'm just gonna get there you go. And I've graphed them. Obviously, the 2 points on the side there, on the middle, should be on the line. They're not on the line because my spaces are not properly spaced out when I drew this. If you are using regular line paper, this might happen. Don't be alarmed. Just do your best to make sure the line fits to it. But that's pretty much it when it comes to the problems that I'm requiring you guys to do, right? For the homework and practice 1 through 6, you're going to have to do these 5 steps. But for 7 through 12, you're just going to have to tell me whether something is continuous or whether something is discrete. Now, we went over continuous and discrete a couple of weeks ago. In case you forgot, here are the notes for discrete and continuous, right? So in this case, the definition for discrete is a graph that is made up of unconnected dots versus a continuous graph is a graph that is made up of connected dots, right? So there is a very important difference that you're going to have to determine, right? So in this case, sure, if I showed you any kind of graph, I am positive that every single one of you would be able to look at it and tell me, yeah, that's discrete, that's continuous, because you just be looking out for the lines that are connected and which ones are just dots, right? You could do that. What the difficulty is going to increase this week because what's going to happen is I'm going to give you a scenario and you have to kind of reason and tell me whether or not, if you were to graph it, you're not going to graph it, but if you were to graph it, would this be discrete and would this be continuous, right? How do we do that? Well, let's look at the example that I have here, right? Under the discrete, notice I have 2 graphs, right? Next to each other. The ones to the left under the discrete right here, right? It says cost and the number of apples, right? Now cost is going to be on the y-axis, and the cost is going to be in dollars. So that represents $1, $2, $3, and $4. On the bottom where it says the number of apples, right? I have 1, 2, 3, and 4. So this kind of represents a scenario where you would go to the store, and the store has 2 options, right? The store is either going to charge you the same amount for every single apple, no matter what the apple looks like, or the store can be like, you know what, we're going to charge you the amount of, well, we're going to charge you depends on the amount of pounds, right? One of these is discrete and one of these is continuous, right? So in the example for discrete, it says a function representing the sale of individual apples is the discrete function because no fractional part of an apple will be represented in the table or the graph. Okay, so what this means is under this system, right, how can I tell that this is discrete? Well, if the store was telling me every apple is $1, just $1. It doesn't matter how big the apple is. It doesn't matter if they're tiny, if they look weird. You want to buy an apple, it's $1 flat rate, right? Only one of 2 things can happen here. Either I can say I'm not going to buy any, right? I'm going to buy 0 and I'm going to spend 0 money. So that's going to be at origin 0, 0, right? I buy 0 apples and I spend no money. Or I buy 1 apple and I spend $1. I buy 2 apples, but they're not connected. The reason why they're not connected is I can only really do one of those things at a time. Each one of those dots are not connected to each other. They're independent of each other. That makes them discrete. Versus continuous is different. I believe last time I described continuous as a way of measuring something that is uninterrupted, kind of like time, right? In this case, this example is still going to be with the store example, but we're going to change it a little bit, right? A function represents a sale of apples by pound as a continuous function because any fractional part of a pound of apples will be represented in a table or graph. What this means is um, the cost, I can be charged any amount of money from $1 to $4, right? But it all just kind of depends on how much uh, the bag of apples or the amount of apples that I'm trying to buy weighs. Every single apple is not going to weigh 1 pound, all right? Every single apple is going to weigh a little bit differently. And what this is doing is it's saying, yeah, if I happen to find one freaky looking apple that's huge, right? And it's is exactly 1 pound, right? Sure, I'll probably have to pay the $1, right? That's what this dot represents. And that's what 4 of those dots represent as well. However, any one of the points that are in between are also possible, and that's what makes a continuous graph continuous. What that means is, what if I get a bag of apples, I go to pay for them, and instead of it being 1 or 2 pounds, if it's 1.5 pounds, right? How much am I gonna pay? Well, in between $1 and $2, right? It all just depends. But I'm allowed to buy anything, right, in between those pounds because we're going by pounds instead of by the number of apples. Number of apples is discrete, pounds is continuous. When it comes to this, when you're doing 7 through 12, right, you just have to tell me if something is discrete or continuous. You don't have to graph it out. You don't have to, you're going to look at the scenario and you're going to be like, this is continuous, this is discrete, right? And you're going to just give me a real quick reason why, okay? So with that in mind, I have terrible writing. All right, so homework and practice. You guys are going to do numbers 1 through 6, 7 through 12. And I want you guys to take a crack at 13 and 14, which are kind of a combination of problems, one of these problems. 1 through 6 are the graphing steps. This is the one where I want to see all 5 steps, but if and only if the equations are linear. If they are anything other than linear, do not graph them. 7 through 12 are going to be the continuous versus discrete questions. For 7 through 12, all you have to do is just tell me, is it continuous? Is it discrete? What made you think that? Right or wrong? I just want to see your thought process. So just pick something and just give me a reason why you think that. And then if you're completely off, then I'll just talk to you during the Zoom and see if we can't clarify this. All right. 13 and 14 are your word problems. Once again, if you check in through Zoom at least once a week, if you have questions about this, even better, that's the perfect time to go and ask me. Zoom office hours are from 1:30 to 3 p.m. Monday through Thursday. Okay. Good luck, guys. Turn everything in, and that's it. Okay. Okay, there it goes.